Hey guys. So yesterday we talked about um, special triangles. We talked about a 45, 45, 90, and a 30, 60, 90 triangle. And today we are looking at something a little bit different. We're looking at a trigonomic ratio, which is a ratio of the lengths of two sides of a right triangle. So we're still staying in our right triangle study, but we're looking specifically at the tangent ratio. So the tangent, also called tan, is a ratio of two specific sides of a right triangle. One of the sides is the side opposite of the angle, and the other is the length of the side adjacent. So we are looking at these two lengths that can give us what's called the tangent. So, for instance, if we are looking at tangent A, we would say that the side opposite of A is directly across from our angle A, and the side adjacent to A would be this side. Okay? Now, it wouldn't be this side because the side opposite of the 90-degree angle is called the hypotenuse. So every angle here, or every length here, side here, has a specific name. So for this A, it's the side opposite over the side adjacent. Okay? So we're always looking at the trigonomic ratio, or the tangent is in an acute angle, is one of the acute angles of the 90-degree angle. Hope that makes sense. I think an example will help. So, one other point I want to make. One easy way to remember this is to just remember TOA. Opposite over adjacent, also known as TOA, T-O-A. I have did the exact same thing when I was learning this forever ago. You will always remember these trigonometric ratios by these little words like TOA. We'll get into other ones today. We're going to take it nice and slow. We're just going to look at tangent. We're going to add to our word here, our long word that we're going to remember, but that is to come. But today we're just going to stay looking at tangents. There's other ratios that we're going to get into this week, but for now we're just going to look at the tangent. So if you are following along with me in your book on page 489, they give you an angle PQR, and in this angle, or this triangle there, it is, of course, a right triangle. So our right triangle is here. And then we have Q here, P here, and R here. So our example asks us to find the tangent. So find the tangent of angle P. So that would be this angle here. So the first thing that we would do is we're going to label our sides. That's going to help us out. So our side opposite of the 90-degree angle would be our hypotenuse. We don't need the hypotenuse for our, if you remember, tangent is our angle opposite over side opposite over our side adjacent. So we don't need the hypotenuse, but we're going to go ahead and label it so we don't get confused and accidentally think that that's our adjacent angle, right? So our side opposite of P would be right here on this side opposite. And then our side adjacent would be right here. Okay? So this would be our side opposite, and this would be our side adjacent. Okay? So we labeled our sides. Now, in this problem, we see that the hypotenuse length is 85, and we see that our side adjacent is, let me see, 36, and our side opposite is 77. Okay? So, after we can, just to get this a little clearer. So we're going to take our side opposite 77 and put that over our side adjacent, which is 36. So our tangent of angle P is 77 over 36. Okay? So what if we were to ask what the tangent of Q is? Remember, this is a 90-degree angle. Tangents are relating to the one of the acute angles of a 90-degree angle. So this also is we can find the tangent of Q. So if we find the tangent of Q, get this cleared up a little bit. First thing we would do, if we're looking at Q, in the same triangle there, we're looking this way. So for Q, our side opposite is here. And this still remains the hypotenuse. That's the hypotenuse is the side opposite our 90 degree. So that's our hypotenuse. And now our side adjacent is here for angle Q. Okay? Again, we said that PR, line segment PR, the distance is 36. And the distance of our line segment QR is 77. So if we're finding the tangent or tan of angle Q, we still know that that's the side opposite over the side adjacent. So now our side opposite is 36 and our side adjacent is 77. So the tangent for angle Q is 36 over 77, and the tangent for angle P is 77 over 36. And that is one example of a trigonometric ratio. That's called the tangent. So remember tangent, TOA? I'm going to give you a few problems today that you're going to look at. You're going to find the tangent of some of these angles. The first thing I would do again is make sure that you label your sides so you don't get it confused. That's the only thing really you can mess up here with. Just always, the first thing you should do is know that the hypotenuse is opposite the right angle. And then whichever angle you're looking at, the side opposite is going to be the side opposite of the angle that you're looking at, and adjacent is going to be to the side of it. Okay? So I hope this helps. I've got a few problems for you. Tomorrow and the next day, we'll look at a few other trigonometric ratios, cosine and sine. But we're going to take this nice and slow today, and we're just going to look at tangent, focus on that, and then we'll look at sine and cosine later this week. Hope y'all are doing great.